Now, notation. In many ways, it is a beautiful thing that in calculus, multiple mathematicians discovered or created calculus at roughly the same time. And we've had a discussion about Newton and Leibniz. Now, a drawback is we have a lot of different notation because of this, because Newton had one way he liked to notate things, and Leibniz had a different way. I will admit, students really like the Newton way of notating derivatives. It's a slight change. Newton actually did it with dots on top of his function names, and he called them fluxions. Uh, but the dot kind of started migrating down, and it's turned into this what we call prime notation. So whenever we see this, it looks like an apostrophe, but we say prime when we see that symbol. So this would be f prime of x. This would be y prime. And Newton's notation is really nice because it's very brief, it's very quick to write, it's easy to write. Um, it's it's very minimalist. Uh, a drawback comes in that when we want to work with multiple variables, especially multiple independent variables, it doesn't tell us what the independent variable is. Uh, so there are going to be some scenarios in calculus where we will say, yeah, Newton's notation is great, but we can't always use it. Uh, Leibniz notation uh, takes advantage of the fact that as rates of change or as slopes, these are really ratios, and it helps make the derivative notation look like ratios. So here, dy over dx, we never really say the word over. We would just say dy dx, or this would be df dx, or this is d dx of f of x. Uh, so we kind of skip saying the word over, but when we look at it, the d actually stands for little tiny change. So remember that when you find slope in grade school, the old school slope, you wrote delta y over delta x to stand for change in y over change in x. Well, this still means change in y here over change in x, but the using this d means it's little tiny changes, infinitesimally small changes of y, and infinitesimally small changes of x. So we are stressing the fact that this is a slope. Uh, so it is more annoying to write, but it is more descriptive of what is happening in that it's being written as a slope. It's also telling me y is the dependent variable and x is independent. Or if I'm looking at df dx, it's a slope, change in f over change in x, but this is now also stressing that f is my function name. So if I wanted the derivative of k of x, I would say dk dx. This last one here is rarer. Um, it's it's kind of a personal. This is probably the only one I personally don't use a ton. Uh, you will see, however, that this is one that our calculator will use. And so when I go over how to do derivatives on our calculator, this is a notation we're going to see on the calculator. In terms of these other four, though, I evenly use the notation from Newton, the prime notation, and Leibniz's ratio notation.